Good evening, everyone. So today's topic is DHCP Snooping, basic concepts and configuration. So uh, we have DHCP server in our scenario. We have 4 clients, and we are making this Cisco router to act as a DHCP server, and the network is 10.0/24. So the IP address for this DHCP server is 10.0.0.1, 255.255.255.0, no shutdown and exit. Now we will create a DHCP pool by the name crypto. Network is 10.0.0.0, 255.255.255.0, and the default router is 10.0.0.1. The DNS server is 10.0.0.80. We will exit and now run IP DHCP excluded address 10.0.0.1 and 10.0.0.80. So these two IPs we don't want DHCP server to offer to any client. Okay, now when we check on these PCs, the dynamic IPs are from 10.0/24 network, and they will ping each other. The IPs are 10.3. The default gateway is 10.0.0.1. The DNS server is 10.0.0.80. So the configurations are as per the requirement, as what we did in our DHCP server. Okay, so in a given network or segment, only one DHCP server should be running, and if more than one is running, they will clash with each other over which one provides the address, and this can cause duplication of TCP/IP addresses and potentially lead to addressing conflicts. So when we ping 10.5, we are getting a reply, so all the PCs are communicating with each other. Okay, so what happens if an intruder uses a DHCP spoofing device to send replies to DHCP requests ahead of replies from the real DHCP server? Okay, so we have added one rogue DHCP server here. We are configuring this rogue DHCP server the same as we did our real DHCP server. The network for this DHCP server is 192.168.1.0/24. And now we will exit and IP DHCP pool. The pool is rogue. Okay, now network is 192.168.1.0. the net mask is 255.255.255.0. 5.0. The default router is 192.168.1.1, and the DNS server is 192.168.1.80. We'll exit and we'll run IP DHCP excluded address 192.168.1.1 and 192.168.1.80. So we'll exit from here, and okay, so now some of your computer users have suddenly started calling you to indicate that after rebooting their systems, they can no longer access network services or the internet. And after investigating the situation, you discover that the IP addresses they are using are invalid for your network. However, the IP addresses are valid, but they are not part of your network. So the IP address for PC1 is from 192.168.1.0 network, The default gateway is 192.168.1.1 and DNS server is 192.168.1.80. So if PC 0 wants to communicate to any of the PCs, PC 0 will not communicate, so getting the request timed out error. And the short answer is that the device that requested the IP will normally take the IP that gets sent to it first. So this is called a rogue DHCP server, and it can be done maliciously, either to deny clients from working or to route their traffic through a sniffer in order to extract private information. And to overcome the easiest solution for this is DHCP Snooping. And I'm not certain if this is available on other switches, but yes, it is a feature of CISCO switches. So the way it works is that you tell the switch that DHCP responses may only come from certain ports, and these ports would be the trusted DHCP server or any upstream switches. So here in this scenario, the trusted port is fast Ethernet 0/1 that is connected to real DHCP server, and rest of the ports are untrusted ports. So let me note that trusted port is fast Ethernet 0/1 and the untrusted ports are fast Ethernet 0/2, 0/3, 0/4, 0/5. Okay. So we will configure DHCP Snooping in our switch, in our CISCO switch. So this is not enabled by default. We have to configure. We have to enable. So to begin enabling DHCP Snooping, use the global command IP DHCP Snooping, and okay. So before proceed further, we will look into the show IP DHCP Snooping binding. So none of the IP addresses are bind with any of the hardware address. So DHCP Snooping is enabled because we have enabled IP DHCP Snooping command. Okay. So now the next configure the VLANs you want to protect using the IP DHCP Snooping VLAN 1. So here in this case, VLAN 1 is the only VLAN. Here we are monitoring only VLAN 1, but we could easily include a range of or sequence of VLANs. And finally, we need to tell the switch the port to which our trusted DHCP server is directly connected. So in our case, fast Ethernet 0/1 is directly connected to DHCP server, and we want this port to act as a trusted port. So now DHCP Snooping trust. Okay, now exit. Okay, so DHCP Snooping is built on the concept of using one or more trusted ports that have been identified as having legitimate DHCP servers attached. And one more command we have to run on our DHCP server, that is IP DHCP relay information trust all. Global configuration mode, we have to run this command. Now exit. Okay, all right. So as clients communicate on the network, the switch builds a binding table, that is a database that lists the client's MAC address, DHCP assigned address, switch port, VLAN, and remaining DHCP lease time. So now when we reboot all the clients, the IP address is from 10.0/24 network. So all the clients will get the IPs from 10.0/24 network, because only the DHCP server, the real DHCP server, is assigning the IPs to the clients. Okay, so the network switch filters any DHCP server messages from untrusted ports in order to protect the integrity of legitimate DHCP servers and their operation. So when we verify show IP DHCP snooping, fast Ethernet 0/1 is the only trusted port among all. So fastnet 0/2, 3, 4, 5, all the ports are untrusted ports. Let us introduce some of the clients in this environment, and we will see from which DHCP server these clients will get the IPs. So it might take some time because the ports are not enabled as a port fast, so we have to wait for a couple of seconds. Okay, so one should remember that the binding table is stored locally in memory, but can be exported off box via TFTP or FTP, and exporting this information is considered best practice in case the CISCO switch unexpectedly reboots and loses all the data. Okay, so now on PC4 the IP address is 10.6, the PC5 the IP address is from 10.0/24 network, the default gateway is 10.1, DNS server is 10.80. Okay, fine. So we again verified show IP DHCP snooping. The ports, newly added ports, fastnet 0/7 and 8, they both are untrusted ports. Only one port act as a trusted port, that is fast Ethernet 0/1. Alright, so last but not the least, I would encourage anyone interested in deploying DHCP snooping in a production environment to test it in the lab first. Yes, to ensure a complete understanding of how the feature is intended to work. That is all in this video, and we will come with more advanced configurations for exporting the DHCP bindings and rate limiting DHCP server responses, as well as manipulating which hardware addresses are used for verification. And thank you for watching this video. Please like, share and subscribe our channel Crypto Network. Thank you all for watching this video again. Have a good day. Take care. Bye-bye.